There are times in life when it's easier, safer, or more convenient to use a placeholder to represent something or someone else. Individual representatives may be sent to speak on behalf of a company at a conference. Crash test dummies are used instead of real human beings for vehicle collision testing, and a credit card is an acceptable form of payment in place of cash. In each of these situations, an object is represented by a proxy object. The proxy acts as a simplified or lightweight version of the original object. A proxy object is still able to accomplish the same tasks, but may delegate requests to the original object to achieve them. We encounter similar issues in software systems where it is better to use a proxy object in place of the original. This is the goal of the proxy design pattern, which allows a proxy class to represent a real subject class. In this design pattern, the proxy class wraps the real subject class, that is, hides a reference to an instance of the real subject class. The real subject class is a part of your system that, for example, may contain sensitive information, or would be resource-intensive to instantiate. Since the proxy class acts as a wrapper, client classes will interact with it instead of the real subject class. Why do we want to use a proxy class? The three most common scenarios for them are 1. To act as a virtual proxy, where the proxy class is used in place of a real subject class that is resource-intensive to instantiate. This is commonly used on images in web pages or graphics editors, because a single high-definition image can be extremely large. If you were to load all of these images at once, it could put a strain on your system's resources. 2. To act as a protection proxy in order to control access to the real subject class. A protection proxy can be used in a learning management system that checks the credentials of a user, so that different users, like students and instructors, can only access the appropriate functions permitted by their role. And 3. To act as a remote proxy, where the proxy class is local and the real subject class exists remotely. Think of this like working on a Google document, where your web browser has all the objects it needs locally, which also exist on a Google server somewhere else. Let's take a look at the general classes and structure of the proxy design pattern. The proxy class wraps, and may delegate or redirect calls upon it, to the real subject class. However, not all calls get delegated because the proxy class is supposed to act as a lighter version of the real subject class, and can do some of its lighter responsibilities. The proxy class will only redirect more substantive requests to the real subject class. But what calls need to be supported in the proxy class? Since the proxy class is meant to stand in for the real subject class, it must offer the same methods. You can ensure that by having both these classes implement a common subject interface, which also allows for polymorphism. Since the proxy and real subject classes are both subtypes of subject, a client class can interact with the proxy, which will have the same expected interface as the real subject. Let's take a look at a practical application of the proxy pattern. Suppose you run an online retail store with global distribution and warehousing. How would you know which warehouse to route orders to fulfill customer orders? You may run into an issue where you route orders to a warehouse that doesn't have stock for an item in a customer order. You need some way to determine which warehouse to send the orders to. A system that routes the orders for fulfillment to an appropriate warehouse will prevent your warehouses from receiving orders they cannot fill. So, how would you implement this system? You can use the proxy design pattern to have a proxy protect your real subject, the warehouses, from receiving orders if the warehouses don't have enough stock to fulfill an order. The iOrder interface defines how you would fulfill the orders. The proxy class and the real subject class will implement the interface differently. This interface declares how to interact with your order fulfillment system. The order fulfillment class acts as the proxy for all your warehouses. It has a list of warehouses that it can delegate parts of customer orders to depending on whether or not a warehouse is capable of fulfilling a part of the order. The warehouse class is your real subject class and will be responsible for actually processing and fulfilling parts of customer orders. The warehouse class will report its inventory to the proxy that asks for it. As shown in the general design overview for the proxy design pattern, the client will interact with your system by using the interface. Now that you've completed the design for your order fulfillment system, the next step is to implement it. Step 1. Design the subject interface. Create the interface that client software will use to interact with your system. This interface will be implemented by the order fulfillment and warehouse classes. Step 2. Implement the real subject class. The warehouse class knows how to process an order for fulfillment, and it knows how to report the current stock of items. Notice that it doesn't need to check if it has enough stock to fulfill an order, because an order should only be sent to a warehouse if it can be fulfilled. Step 3. Implement the proxy class. The order fulfillment class does all the work of checking the warehouse inventory and ensuring that an order can be successfully completed before sending the request to the warehouse. It will ask each warehouse about whether it has enough stock of a particular item. If the warehouse has enough inventory, the item gets added to a new order object that will be sent to the warehouse. The proxy class ensures that an order can be fulfilled before sending the request to your warehouses. This protects your warehouse system from receiving orders it cannot fulfill. The order fulfillment class also lets you separate order validation from the order fulfillment by separating them into two pieces. This will improve the overall rate of processing an order because the warehouse doesn't have to worry about the validation process. Each individual warehouse also doesn't need to worry about how to reroute an order if the warehouse can't fulfill the order. The order fulfillment class can be improved with other functionalities, such as prioritizing sending orders to warehouses based on proximity to the customer, to ensure that orders arrive as fast as possible. The proxy design pattern is useful when you need to defer creating resource-intensive objects until needed, control access to specific objects, or when you need something to act as a local representation of a remote system. To summarize, the main features of the proxy design pattern are to use the proxy class to wrap the real subject class, to have a polymorphic design so that the client class can expect the same interface for the proxy and real subject classes, to use a lightweight proxy in place of a resource-intensive object until it is actually needed, to implement some form of intelligent verification of requests from client code in order to determine if, how, and to whom the request should be forwarded to, and to present a local representation of a system that is not in the same physical or virtual space. The proxy design pattern provides your system with a powerful means of indirection. Proxy classes are robust and can let you build systems that are more secure and less resource-intensive.